Kind your audio and video. A very good morning to all of you who have joined here. We welcome you for this national level webinar on fuzzy decision making models. Dear participants, kindly disable your audio and video. Department of Mathematics, St. Joseph Institute of Technology welcomes you for this national level webinar on fuzzy decision making models. A humble request from our side. Dear participants, kindly disable your audio and video. Do not try to present your screen while the presentation is going on.
Sir, unmute your video sound. Satish sir.
A warm welcome to all of you who have joined here. On behalf of St. Joseph Institute of Technology and Department of Mathematics, I take immense pleasure in welcoming you to this national level webinar on fuzzy decision making models. Today, we are honored to have Dr. A. Felix to enlighten our knowledge. Professor Dr. A. Felix is from Department of Mathematics, School of Advanced Sciences, Vellore Institute of Technology, Chennai. He received his doctoral degree from the University of Madras, Chennai. His doctoral research was on an extension of fuzzy D-metal techniques to analyze dimensions of personality and aggressive behavior in youth. He is an alumnus of Loyola College, Chennai. He is having 9 years of teaching and research experiences. Currently, 4 students are working under his guidance. He has published more than 40 research articles in reputed journals. He received Young's Researcher Award from Integrated Intelligent Research during the year 2017. He is an esteemed specialist in the field of fuzzy model and its applications. He is an esteemed specialist in the field of fuzzy models and applications. He is a reviewer of a Journal of Ambient Intelligence and Humanized Computing. He is a well-known speaker as he has delivered his lectures in various institutions. Such a renowned person is our today's speaker. His accomplishment is a big list. We are very much delighted to have you here, sir. We thank you for acknowledging our invitation. Once again, I extend a cheerful welcome to you all. Your presence makes us very happy. I hand over the session to Dr. A. Felix, sir, to elaborate on the topic.
Felix sir, unmute yourself, sir.
Is my screen visible, sir?
Yes, sir. Visible.
Yeah, thank you. Very good morning. At the outset, I would like to thank the management of St. Joseph Institute of Technology the chairman, managing director, the director, and the principal of this college, the conveners, Dr. T.T. Raman, Professor and Ed, Dr. T. Kalyani, Professor, and the coordinators of this webinar, Dr. R. Prabhakaran, Dr. M. Elumalai, and Dr. K. Satish, for this providing this wonderful opportunity to interact and meet you all through this webinar. The title of my talk is on fuzzy decision-making models. The decision-making task is not an easy task. Suppose you want to buy any good mobile phones. So usually, we would ask with our friends who is really expert on mobile phones. So we will get we will get the information. From that, we'll take a decision. Okay, whatever he directs, then we are going to buy the mobile phone. So similarly, we have come across many situations to take a decision. Okay, to take a decision, we have a lot of alternatives. Among the alternatives, we are trying to find out the best alternative. This is what the decision making is all about. Okay, so in this decision making, human or succeed, though we have a lot of information on it, whether we do not have inadequate information, we are able to take a decision. Okay, so we can take a decision with our knowledge, with our empirical analysis, we can take a decision. With our experience, we cannot take a decision in all sort of situations. We need some scientific methodology to take a decision. And the fuzzy logic is one of the technique which resembles the human way of thinking, which helps us to take a decision when we do not have enough information about a particular task. So this fuzzy logic will help us to take a decision meaningfully. Among the several alternatives out there, we are able to take the best one. Okay, so here we will. I would like to give this apple to all of you. Usually, I would do this. Okay, to present this virtual apple to all of you. Please taste it. Okay, the outline of my presentations is introduction to fuzzy sets, the extension version of fuzzy sets, the membership functions of fuzzy sets, properties of fuzzy sets, fuzzy numbers and arithmetic operations, the decision-making models. Okay. We know the classical set. A classical set is defined as the collection of well-defined objects in which the membership of an element takes value either 0 or 1. 0 means do not belong in an element, do not belong to this set. Initially, are given a apple to taste. Is it tasty? Your answer would be either yes or no. It is in the form of classical aspects. But here you cannot see, you cannot give that somebody would say that this. The apple is very tasty, medium level, low level, no tasty. But this medium, low, very level tasty cannot be brought into the classical set. Whereas at the fuzzy logic, you can bring the human way of thinking. Okay. Is it tasty if your the answer in terms of the Boolean logical aspects either 1 or 0? In fuzzy logic, which mimics how we think, we the human really think in that aspects. The apple is really tasty, little tasty, very less. So in between this 0 and 1, something is there. We are not in the world certain. We are living in the world uncertain situation. In all sort of situation, we cannot bring or classify into yes and no. In between yes and no, a lot of things are there. The partial truthness are there. We are living in the world with the partial truthness. We can assign this partial truthness between 0 and 1. This is what the fuzzy set introduced. In the year 1965, Lotfi Aliza, which is the matter of degree. the truthness of our language with a certain degree. Okay. So from his work in 1937, Bloch outlined the concept of fuzzy sets, but he was opposed by many people who were at the United States, and he stopped to proceed to work on fuzzy sets. And later in 1965, Zade has given a life to these fuzzy sets, and he described the fuzzy sets in the modern form. The fuzzy set can be defined like this. Fuzzy set, a set, the uncertain situation is there. A set of all intelligent people, a set of all beautiful people, and these are the set. You're in the dilemma that whether you belong to the set. You're not certain that whether you belong to the set. Under the situation, how this fuzzy set can be defined. A is the set of all intelligent people. Here, X is the set of all element, and mu of P of X set X is an element, and mu of X is the membership. And this membership takes between 0 and 1. But when the other people who are to this keep on asking this, that in probability theory also the values are taking between 0 and taking between 0 and what is the difference that we definitely come encountered this kind of question. Of course, probability theory were used to solve the uncertainties in those days, but probability theory cannot quench all sort of uncertainty. I'll tell you. So this, since I've given apple, let me give an example.
Yes, sir, you are audible, sir.
Okay, thank you. Okay, so I'll give an example. Suppose my intention to have a apple with a red color and tasty as well. And what is the guarantee that I'll get the apple in the market? This is the first question. And second one, what is the possibility that the apple is tasty as well as red color? The first question, the availability of the apple in the market can be done by the probability theory. The probability value can be assigned by the season. Season will determine whether I can get the apple in the market or not. The second one, the tastiness of the apple or the colors of the apple. The color may this kind of valued this cannot be done by your probability theory, because your probability will tell you only two value, either you will get or not. But here we have come so many valued. This value cannot be done by the probability, whereas our probability theory can deal. So with this information, the fuzzy sets were successfully applied in the many field: data classification, decision analysis, expert system, time series prediction, robotics, and pattern recognition, and so on. And one of the beautiful applications of fuzzy logic through which they can stop and start the train smoothly, which acts 10% more efficient than the human control acceleration. So the application part has been successfully applied by the Japanese people, that we put washing machine, and AC. So because of this application, fire appreciated very well, and it became a renowned tool now. The fuzzy set focused on the membership grade, whereas the intrinsic fuzzy set focused on the non-membership. The intrinsic fuzzy set were proposed by the Antonosov. The intrinsic fuzzy set is the order triple X is an element of A, mu of X is the membership, V of X is the non-membership. The sum of membership and non-membership value lies between 0 and 1. And if you want the example for the intrinsic fuzzy set is, so for a particular patient in a medical diagnosis example, let me give a particular patient, the curability of a disease by the expert doctor is 60%. This is 0.6 is of curability, and percent of durable of this disease. Version, the only difference is the non-membership and membership and non-membership. When greater than or equal to 1, this will hold this condition. Sum of square of the membership non-membership excitation is 1, that is Pythagorean fuzzy set. And people are also looking extending the fuzzy sets into the nucleosophic fuzzy set, picture fuzzy set, spherical fuzzy set, type 2 fuzzy set, soft fuzzy set, rough fuzzy set. Okay, so the people who are interested to work on the fuzzy set kindly explore. This is with a different situation. They brought the fuzzy set. But you should know when the fuzzy set is used, when the situation is uncertain, and where you can use the fuzzy sets. So this is the example that you have seen already. Okay, so the height of the people. For instance, the person height is 5.10. More than 5.10, this is assigned a membership is 1. Less than 5.10 will be assigned a membership. Less than 5.10, membership grade is 0. So the person height is 6.5, who is also assigned a membership grade is 1. 5.10 is also assigned to 1. What is the difference? So to answer this, the fuzzy set is brought into the picture. Okay, so 6.2. So look at this, more than 5.10, the 5.8, 10 maybe the height is 0.7, 6.2, 0.9, and 1 it goes on. This fuzzy set provides the natural way of dealing this set of all tall people. The person height is really 6.2, his grade is height is 0.9. This example you will learn from everybody. This is basic in fuzzy membership function. The support, core, alpha cut. So here the alpha cut is really matter. The alpha cut is the after assigning a membership grade. This is the typical structure of the fuzzy membership function. The bell-shaped curve is the typical structure of the fuzzy membership function. Okay. So here the alpha cut is a set of all elements with greater than or equal to alpha will be the alpha cut. Even we are keeping the cutoff. The people who scored more than that, who will enter into the particular institute. Okay. Similarly, the height is the maximum degree of membership. Crossover is the element having the membership is 0.5. Similarly, a set is a normal with the height is 1, subnormal. These are the basic information you might. I think I can spend the time here. The convexity of the fuzzy set. Okay. So the convex set. Take a 2 point in a set. The line segment completely lie on the set. That is the convex set. How the convexity can be defined at the fuzzy set. The fuzzy set is the convex if mu of f lambda x1 mu of lambda x1 plus 1 minus lambda of x2 greater than or equal to minimum of mu of x1 mu of x2. So look at this set. This is the fuzzy set. Here x1 x2 is taken. The membership of x1 is 1, x2 is 1. Take this lambda x1 plus 1 minus lambda x2. Lambda of x1 plus 1 minus lambda of x2 greater than the minimum of membership of x1 and x2. So this will hold the condition. Therefore, this is the convexity, whereas this is not a convex because this value does not greater than or equal to minimum of these two. Similarly, we can define the symmetry as well. So the one open left, open right, and closed. So look at this. When x tends to minus infinite, the membership value is 1. And when x tends to positive infinite, the membership is 0. This is called open left. Similarly, we can define open right. Okay, I'm trying to cover in a very brief manner. There are various types of membership functions are there. The first one is the triangular membership function. Okay, so this is uncertainty at a point. This is defined like this. Okay, so when x lies between a and b, this is defined as x minus a divided by b minus a. Similarly, x lies between b and c, the membership will be defined. We can also define this using the maximum operation. Okay, and the alpha cut of this two alpha cut of membership function can be given in terms of the interval form. Okay, so and then we can also define this triangular membership function in terms of the width this portion. Similarly, okay, this is one way of through later, because I'll go a little past this preliminaries with this preambles which are required for our decision making model. Similarly, the trapezoidal, the uncertainty at the interval. When the uncertainty arises at the interval, then this interval approximately expressed in terms of like this, in terms of the trapezoidal membership function. The trapezoidal we can define like this. Okay, when x lies between b and c, membership is 1. The rest of them, it is defined like this. So we can also define using the maximum operation. Okay, so this is one of the we can also define the center and the width like this. So another one is the LR type of fuzzy membership function that I told you. Okay, when this left width and right width in the form of the function, how one can define the LR type of membership function. If x tends to minus infinite, this side is positive infinite. Okay. Then, so what will happen? So if you substitute t here, what will happen? Something a here. So a with this will be 0. L of 0, the membership is 1. Okay, that's what L of 0, and the R of 0 is 1. If you take a minus alpha, t as alpha minus a minus alpha, then what will happen? You will get alpha divided by alpha, then you will get L of 1. So this portion, you have taken this alpha a minus alpha, this membership is 0. So we can also define the membership function in terms of LR type. Okay, so quasi fuzzy membership function. The only difference is here when t tends to infinite, to the left side and right side is 0. That's the only difference. The people who can who are interested to work on the fuzzy number, please explore on it. Okay. There are other type of membership functions. This is for non-linearity case. Gaussian membership, bell-shaped sigmoidal membership function. This is one of the predominant membership function that has been applied at the neural network. Whereas the linear, the triangular, trapezoidal are very well applied in all sort of decision-making problems. Okay. So other types are there. So S plus and S negative membership function, the extension version of membership function, pentagonal, hexagonal, heptagonal, and intuitionist fuzzy membership function. You can also explore this membership function with the other fuzzy sets, extension of fuzzy sets. Okay. Some standard operation that we can explore here. Okay, A and B are two fuzzy sets. The inclusion of fuzzy sets can be defined if the membership of all A less than or equal to the membership of B. Okay. Similarly, the equal of fuzzy sets. If A and B are equal, if the membership of an element of A equal to the membership of element of B are same. Similarly, we can define the complement of a fuzzy set. The combination T norm and T conorms are nothing but the and or operation respectively. The T norm is defined as, suppose if you want to find out mu of A intersection B of X, this can be defined using the T conorm, T norm, T of mu of X, comma mu of B of X. This T is defined. Okay, so this is nothing but the triangular norm which satisfies the commutativity, associativity, monotonicity, and neutral element. Okay, this and operation is defined as minimum between them, between the membership of an element of a set A and B. And then the product also is applicable for AND operation. If you want, we can take example. A and B are two fuzzy sets. The A intersection B, the minimum between them, and then A dot B, the product of these two. So product of the A dot B and A union B are also used for the AND operation. Okay. The other versions. Okay. So both the techniques holds this condition, the T norm conditions. Okay. This is for Boolean AND. In discrete mathematics, we have seen A and B are two statement. The possibility, the truthness of the statement is 4. Okay. A intersection B, the minimum between them is taken. Okay. This is what given in terms of the T norm aspects, and this is also holds good at the fuzzy end. When you extend the Boolean AND into the fuzzy end, it holds. Even if you want, you can check 0.75 this portion. A is with the membership grade 0.75, B is with the 0.5. So minimum between them 0.5. Similarly, the AND operation, Lukowicz conjunction, Himachar conjunction, so many conjunctions are there. So you can also explore on it. So I will also share this PPT. You can go through that. Okay. The R operation. Similarly, this R is nothing but T co-norm. Okay. R S norm. It is also referred as S norm. A union B of X is equal to T of mu of X comma mu of B of X. Okay. The T co-norm is defined like this. T is nothing but triangular. The fuzzy R, the maximum of these two. The product is nothing but, what is it? This is nothing but, what is it? Inclusion exclusion principle. Okay. So when you add A and B, this portion is added twice. Therefore, here we are subtracting by doing or taken for OR operation. Okay. This is T co-norm. Okay. Similarly, we can the truth values for Boolean R and fuzzy R. Okay. So other version for R is Lukowicz disjunction, Himachar disjunction, Einstein disjunction. You can also try with the same example. How far the results are better. Okay. So the fuzzy sets holds all the law of drift set except the laws or two statement do not hold good at the fuzzy sets 2x. Okay. And law of contradiction. A intersection A bar is empty, whereas A intersection A bar is non-empty. You can see the example of it. Let me go a little past this preambles. This is one of the interesting concepts, the entropy. You know, this will give how we can measure the fuzziness of the fuzzy set. How far the fuzzy set is uncertain or fuzziness. Through this entropy, we can find out. This particular set is taken. By using this entropy concepts, we understood that this particular fuzzy set is uncertain with the 0.249 or 25%. This set is uncertain or fuzzy. Okay. So this entropy concept can also be applied at the decision-making models. So people, please explore the entropy concepts, which is really, really interesting. Okay. With this entropy, we can also find the weights of between the alternatives. So look at this. Let A and B are two fuzzy sets or two attributes. So we can find out the interrelation between A and B. How far the fuzziness there between A and B can be determined through this expression. So look at this. So A and B are two fuzzy set is taken. The interrelationship between when you compare B with A, the uncertainty B is 0.4717. Okay. So kindly explore about the entropy concept, which is really, really interesting. The people who want to do research in entropy, please explore. So you can also make entropy for the extension version of fuzzy sets is there. You can try to define the entropy concepts. Okay. Similarly, we can define the Hamming distance. This is another interesting topic. That's how we can define, through which we can understand how far one fuzzy set is closer to other fuzzy sets. Okay. Another one, relative Hamming distance is there. Relative is nothing but Hamming distance divided by the number of observation. Okay. So you can see this. At the graph theory also, the Hamming distance are very well used to give a distance between any two vertices. Okay, even the hypercube you can take, the distance between any two vertices is 1, distance is 1, then you can have a link. So people who can also explore an Hamming distance, relative Hamming distance. These are the preambles are very well used at the decision making models. Okay, another one, Euclidean distance, Minkowski distance. Okay. So now let's move on to the Cartesian product of two fuzzy sets. So A of X is defined at A, X, B of Y is defined at Y. The Cartesian product is defined as the minimum between mu of X and mu of B of Y. See, for example, A and B are two sets is taken. So look at this, the Cartesian product of X and Y1, the minimum between them is 0.2. Similarly, you can make this matrix. This is nothing but the relation between these two fuzzy sets through which you can also draw the graph. Okay, draw the graph. So this idea initiated the people to work on the fuzzy graph. Okay, now let's move on to the maximum composition. Okay, A and B are two fuzzy relation matrix. Then the composition can be determined by the max minimum of Aij and Bjk. So Aij and Bjk are the matrix of A and B respectively. Okay, so consider A and B are two matrix. Then the composition can be determined. This the first row and the first column of B. First row of A and first column of B. So take the minimum between them 0.2, 0.3, 0.3, 0.1. Minimum 0.1, here 0.2. The maximum is 0.2. Similarly, you can frame this matrix using the max-min composition. The applications of max-min compositions are there in decision-making analysis. Please look into it. Okay, this is one of the beautiful contribution. Okay, so this is one of the beautiful contribution from Zadeh, fuzzy extension principle. Okay, so look at this. The extension principle is the mapping is given, mapping from X to Y. Okay, and the A is the fuzzy subset of your X. Okay, fuzzy subset of your X. The mapping will be given here. What would be the membership of a set B, which is a subset of Y? That can be determined by through this expression. So look at this here. This can be understood through the example. Okay, so mu of B of Y, we are asked to find out what would be the membership grade of B. B is the subset of your Y. Provided that the mapping is given, the membership of A is the subset of X is given. Then what would be the membership grade of Y? B. Okay. So take the inverse of it. So here we are trying to find the maximum of X membership grade. Okay. Provided this inverse of Y is non-empty. If this is empty, then the membership grade is 0. So let us view this with an example. A is the fuzzy set, which is a subset of your X. The mapping is given. That mapping is gamma of x1 to y1, gamma of x2 to y1 to y4. So look at this. This gamma need not be the single valued function. Similarly, x3 to y1, gamma of x4 to y3, so on. Now here we are trying to find out the inverse. So look at this inverse of y1. Where is the inverse of y1? Then what will happen? x5 is there, and then y1. Where is it? Yeah. So inverse of y1 is x2, and then x3. Yeah, inverse of y1, x3. Similarly, inverse of y2, you can find out the inverse of y, you determine. Now what we have to do, we need to find out the maximum of the membership of grade of x1, x2, x3 will be the membership of y1. Let's see this. So mu of b of y1 is nothing but y1. What are the elements inverse of y1? Inverse of y1 goes to x2, x3, x5. So x1 membership grade is 0.7, x2 is 0.7, x3 is 1. The arithmetic operations of the fuzzy numbers. Okay, A and B are two for the triangular fuzzy numbers. The addition is defined like this. So look at this, A and B are two triangle fuzzy number. The addition can be defined like this, 3, 6, 9. So A and B are two fuzzy sets. The addition can be defined 1 plus 2, 2 plus 4, and 3 plus 6, like vector addition. Okay, and then subtraction. Subtraction is defined A1 minus B3, A2 minus B3, whereas B in the reverse order. A3, and then multiplications, 2, 8. The last one is the division. Division will be in the form of reverse. Okay. So people are also working on this arithmetic operations. And if you look at the results of the subtraction division of two fuzzy sets, may not be provide the result in the form of the triangular fuzzy number. Okay, so this is the observation that we could make. The addition and subtraction between fuzzy numbers is proposed. Okay, so A and B are two fuzzy numbers. Then the addition multiplication operator can be defined like this. Okay, under the nutshell, I'll tell you here we have seen the arithmetic operation. At the arithmetic operation, we have used the weakest t norm. By using this, even at the multiplication and the division also, the resultant will be in the form of the triangular or trapezoidal form. Okay. So that is the beauty of this weakest t norm. So here while doing the ordinary arithmetic operation, we have seen this, the multiplication, division and inverse need not be the triangular trapezoidal numbers. Whereas if you use the weakest t norm, so you can look at this, the division also in the form of the resultant will also in the form of the triangle. So multiplication, look at the multiplication. This is also in the form of triangle. So what we can do with the fuzzy number? So we can assign the value for the linguistic terms. So even if you are asked where the impact of COVID-19 very well, or what is in a particular village, what is the impact of the COVID? Here we do not have the available information. When the data are not available well, then we can express this in terms of the linguistic form. This particular village or affected well or more, so when do not have the enough information, we would speak like this. Or if the car goes too fast, then slow down. The fast, slow can be represented the value by the fuzzy numbers. Okay. For example, if you give the no influence, very low influence, high influence, very high influence, can be given a membership rate, a fuzzy number in this form. Okay, low influence. The impact of between these two attributes. Okay, the impact of between this particular village to other particular village on this COVID. So you can give the fuzzy value like this. Okay, now this is our ultimate aim of this talk: fuzzy decision making models. The multi-criteria decision-making model can be divided into two categories. One is multi-object decision-making and another one is multi-attribute decision-making. The first one is multi-attribute decision-making is in the form of decision space and is continuous. And whatever we have learned at mathematical linear programming are coming under the multi-objective decision-making model. Okay, so this helps us to design any particular. And this talk is about multi-attribute decision making. Okay, this is for the discrete decision space. There are so many decision making models out there. Okay, DMATL, Electre, Topsys, Vicar, Promethe. So many methods are there. But at our talk, we'll be learning this Vicar method, weighted product model, weighted sum model, the weighted aggregate sum and product as model. Okay. At multi-criteria decision making model, so these are the 5 components are really, really important. The first one, what is our goal? Suppose my intention is to buy a best mobile phone. So my goal is to buy a phones. So what I'll do, I will ask the experts, okay, the preferences. They would tell you what are the alternatives is there. So what are the alternatives? In the sense, what are the mobile phone, Vivo, iPhone, Nokia, Apple, what are the alternatives are there? But the decision maker knows what are the features of the mobile phone. That will be in the evaluation criteria. Okay, the features. And finally, he will give the conclusion. With this experience, he would tell you, you would analyze the camera quality and then the storage capacity, the processor, everything he might have analyzed since he has experience on it, and then he would give to the conclusion. So for anything, these are the 5 components are important to take a decision. So look at this. This is how the decision matrix will be. A is the, so here the C1, C2, C3, which are the criteria. What are the features of the mobile phones are there? Okay. And the relation is given, the A1, A2, this is the relation between them. The first mobile phone, and this is maybe the camera quality. So what is that? So each features are weighted. Okay. This is the decision matrix. This is, for example, the decision matrix for it. So these are the alternatives, and the criteria: cost, storage, camera, looks are the criteria. So this is how we can frame a decision matrix. So here the first method is weight sum model, weight product model. The weight sum is introduced by Fishburne in the year 1967, which is the maximum of the sum of the weight of the alternative, I mean criteria, and the QJ. So which is the actual value of the ith alternative and jth criterion. Similarly, the weight product model, the maximum of the product of the Rij power of Vj. Rij is nothing but the same thing, the Qj. The Qj and Rij is same. The actual value of the ith alternatives on the jth criterion. The first one, suppose I want to buy these 2 phones, A1, A2, A3. These are the 3 phones are there. These are the criteria. The relationship are given in terms of the numeral values. Okay, so C1, C2, C3, the camera quality, and then picture, and then cost, camera, and looks. So this is the numeral values given, and then so this features are also weighted. Okay, between 0 and 1, the sum of the weight of the feature is 1. If you look at like this. Okay. So maybe somebody the professors will go for the what is that, storage. C3 is the storage, therefore he is given the preference for 40%. Okay, so C1 is the camera quality, 20%. Similarly, they are given. Okay, the sum of this will be 1. And then the first one is weighted sum model. Weighted sum model in the sense Qij into Vj. If you multiply this, 25 plus into 20, 0.20, plus 20 into 0.15, sorry, 0.15, 15 into 0.40, plus 30 into 0.25. So look at this. Similarly, we have calculated for A2 and A3. So by doing this, we can get to the conclusion. What is it? A2 has got the highest value 22, and A1 21.50, and A3. Therefore, through this weighted sum model, we can come to the conclusion A2 is the best quality or good phone that I can buy. Through the weight product method, what is it? 25 power of 20 into 20 power of 0.015 into 15 in power of 0.40 into 30 power of 0.25. This is 20.63. Similarly, we derive this results. With the weighted product method also, we obtain this results, through which we can take a decision. But here you may have the question: the interrelationship between the mobile phone and the features cannot always bring into the numeral values. Okay, so when the data is not available, when the information is not available, we can express this in terms of the linguistic form. The experts, they will express their view on this particular product, mobile phone, on this features, maybe with respect to what is a low, medium, high, like this you will express when the enough informations are there. That's what I said. So when the enough information and the data is imprecise, at the situation, how we can take a decision. The human can do this with this knowledge he can express. But to express this in terms of the scientific way, the fuzzy logic helps us, fuzzy logic helping us to mimic the human way of thinking, through which the wonderful decision making can be made. Okay, so therefore, here the beauty here is, here we have seen separately weighted sum model and weight product model. And in the year 2012, the weighted aggregated sum product assessment is proposed by combining these 2 models. While combining these 2 models, what can happen? We can save the time. Instead of doing the time complexity can be reduced. You can save our time. When 2 models act simultaneously, you can save the time, through which we can take the wonderful decision. So this method goes like this. So this is the decision matrix. This is the weight of the criteria. Okay, and then the first step, we will normalize the matrix, and then additive relative importance, multiplicative relative importance. We combine these 2. Finally, the ranking can be obtained. Okay, so this you can find the relationship between. Okay, and then second one, the normalize can be done by the Rij divided by the maximum of Rij. criteria is the positive criteria, then all the entries of Rij divided by the maximum of the corresponding column. If the criteria is negative, suppose the criteria is cost comes under the negative criteria, whereas the profit comes under the positive criteria. So if the cost, then minimum from Rij divided by Rij. This formula will be used to normalize the decision matrix, to bring everything into the same pool. And then additivity, the same. This is what we are seeing. Okay, sum of the weighted sum model, and then multiplicative, weighted product, and then these two are combined and taking average. Okay, and to get the accuracy of ranking, this is used with the parameter lambda plus 1 minus lambda. This is we have seen where the convexity we have seen lambda of something 1 minus lambda. Using this, we can find out if lambda varies from 0 to 1, how far the ranking accuracy we can get. Okay, how far we can increase the ranking accuracy. Okay, so suppose I want to buy the machine, the fluid cutting machine, cutting fluid machine. So these are the 4 machines are there. The features of the machines: friction, stoning temperature, recycling capability, work surface roughness, stability. Here, if the machine is recycling, that is the positive for me. Okay, this is my desirable. So therefore, this is the positive criteria. And stability, if my machine works stable aspects, then that is also my positive criteria. So rest of them are considered as the negative criteria. Okay. So the relationship between the machine and the criteria are given in terms of the numeral value. In all situations, we can not provide the numeral values. Okay. And then this criteria are given the weightage between 0 to 1, provided this, the sum of the criterion should be 1. Okay. Look at this. We are given the criterion weight. This is the matrix. And step 1, we normalize the matrix. So we normalized the matrix. And this is the weighted criterion. And then by the relative importance. Okay, so this 0.71 into this plus 0.954 into 0.181, so on, we obtain 0.744. Similarly, we obtain others. Similarly, we obtain remaining. And then the multiplicative relative importance, 0.7 power of 0.331 goes on. Finally, we take the average joint generalization criteria using this formula. And then using here, I've taken lambda is equal to 0.2. By looking at this, you can see this, which one is the, what is the ranking? Q4 is 1, and this is 2, this is 3, and this is 4. But if you find out the accuracy of the ranking, by taking lambda is equal to 0.2, we obtain this results. Through which even by increasing, yeah, the ranking is A4, A3, A2, A1. By taking the different values of the lambda, we can get the table through which the ranking is A4, A3, A2, A1. So here the fourth machine can be opt. So that is the decision we can make. Look at this. So this is we have seen lambda of x plus 1 minus lambda. This parameter we have seen at the convexity case that we are bringing here. So through which, so what the researcher we can do. So we can also extend this method into the fuzzy environment by assigning the linguistic values using the various types of fuzzy numbers. And we can also extend this method, VAST method, in the extension version of fuzzy sets, picture fuzzy sets, so many fuzzy sets we have seen. And we can also use the arithmetic operation, the weakest t-norm operation that we have seen. That operation can also be brought into the picture because here we are using the arithmetic operations. So therefore, various types of arithmetic operation can be brought here, and how far our method acts better than the others. Okay. So we can also, what is that? The entropy concept. I have given the entropy concepts. This entropy concept can also be brought to make the weighted correlation coefficient matrix. So this can be the note to the people who want to do research. This can be, you can take note to explore your research further and further. I told you that here this VASP can also be expressed in terms of the arithmetic operations. So here to demonstrate that, I've taken a Vicar method. Vicar is one of the beautiful method. Vicar topsis are more or less same to each other. The thing is, at the topsis, we'll take the ranking, the maximum value will be taken, or ascending order. Here, the descending order will be taken. Okay. So here, we are trying to find out the compromise solution. So we are trying to compromise everything and go for the taking a decision. Even for sometimes, to compromise everybody, they will take a decision. So in this aspect, this Pekar method works. Okay. The first one, the weighted matrix, the decision matrix, and the weighted matrix is the input, and then the positive ideal solution, negative ideal solution will be taken. Okay. Here, the interrelationship between the criteria, okay, and the alternative will be given in terms of the linguistic form. The linguistic in terms of the linguistic form. So the linguistic table is given here, and then the positive ideal solution, negative ideal solution will be taken, and the index S and R. Okay, the separation of what is it? Separation from the positive ideal solution from your alternative can be calculated by SI, and the R is nothing but the separation of AI from your negative ideal solution. This is SIRI, and then the index QI will be determined. Okay. And finally, we will defussify. For triangular, this is one of the way to defussify, and people are exploring on defussification. You can work on it how the triangular or trapezoidal can be defussified with your defussification techniques. Okay. So finally, we'll get the output. Finally, you can get the ranking. So look at this here. I've taken. I want to buy a mobile phone. Apple, Samsung, Nokia. These are the 3 phones I've taken. These are the criterias: the cost, memory, camera, battery life, screen size, and weight of the phone should also be matter. Okay. So this is the hierarchical structure, and then the interrelationship between the cost and the mobile phone is given by the 5 decision maker. I get the opinion from the 5 people, 5 experts. Okay, the expert is nothing but who knows about the mobile phone very well. He may be your friend or any mobile dealer, anybody. Okay, who knows it, and then the criteria, the cost, criteria, memory, camera are also be weighted by the experts. So finally, the linguistic term are transformed into fuzzy number, and then we combined them together, we get this matrix. Okay. Where here we have used what is it? TW operation. Weakest T-norm operations are used. Okay, to sum in. Okay, weighted matrix, and then the decision matrix, and then here we find the positive ideal solution. So positive in the sense the maximum of them in the corresponding column, which one is the maximum? So this 5.4, 5.8, 6.2 is the maximum. Similarly for all the columns you have determined. The negative is the minimum of it. Okay, minimum is determined. Minimum is 5, 5.4, 5.8. And then we compute the index. So SI is the separation of AI from the positive ideal solution. R is the separation of the AI. A is nothing but the mobile phones from the negative ideal solution. Finally, we compute the index, and then we defussify the concept, defussify everything. Okay, and finally, okay, we have taken the ranking. Okay, so here the minimum is given the highest ranking. So 0.052 has got the minimum element. Therefore, A1 is 1. A1, sorry, A. Yeah. So therefore, compared to 0.52 and then 0.096, 1.831. But at Vicar method, the highest ranking will be given from the minimum. Okay, whereas at the tops is from the maximum. That's the only difference. So here there are both SRQ suggested A1 is the best alternative. So Apple is the best alternative can be bought. So through which you can take a meaningful decision. So at this model, we have used the weakest T-norm operation, okay, through which we can go for the meaningful decision. Okay, so here also you can bring it into the if you are the entropy concepts. I told you, right? So here the entropy concept, if you introduce anything, you can bring here, you can change the weight of the matrix so that still you can get how far your work better than this work, the weakest T-norm. Okay, so I think it is time. Sadish sir?
Yes, sir. Yes, sir. Yes, sir. Can you
Sir,
hear
how
me?
many minutes can I take?
You almost it is 12:30, sir. If
Yeah,
you
yeah.
want to. Hello.
Okay, sir. Let me with that. Let me. You direct me. What shall I do? Sarisha?
Yes, sir. Can you hear me, sir?
Anybody other than ma'am? Yes, sir. Yes, sir. I'm hearing you. You're audible.
Yes. Yes, sir. Yes, sir. Yes,
Sir,
sir.
can I proceed? Yeah, yeah. How many minutes I can take?
You can also
Can I
take,
stop
sir.
or you can?
You can take few minutes, sir. No
Okay.
issues, sir.
So another. Okay, I'll take another 5 minutes. How you can construct other model, how this can be applied in the other aspects. Okay, so here analyzing the risk factors of type 2 diabetes using the another decision making technique. Okay, so here we combined the fuzzy cognitive maps TOPSs together. Okay, so that the first stage, to find out the input variables and classify them into linguistic term and provide the suitable membership function. Okay, and then uh, provide the linguistic terms. Okay, and then find using this CFCs method, you can get the single valued. Okay, so this is CFCs method. Finally, construct the overall relation matrix D of Y D whole inverse, and then this is another one scenario. You will take some different situation. Okay, that the situation can be passed on to this matrix. This matrix considers the decision matrix. Here we pass on to the different situations. Whatever the situation we obtain, that are framed as a matrix, and we normalize the matrix. And at stage 3, we use the TOPSIS algorithm. The people who have worked on the TOPSIS, you can have the better idea on it. So calculate the initial weight, determine the normalized decision matrix, find the positive ideal solution, negative ideal solution, and compute the distance between the positive ideal solution and the alternatives. Similarly, the distance between the alternatives and the positive negative ideal solution. Okay, the distance can be measured through this formula. Finally, the closeness coefficient is determined through which we can take the ranking. Okay, so you know the type 2 diabetes mellitus is one of the alarming diseases, both developing and developed nation. It leads the undiagnosed type 2 diabetes mellitus leads to many situation, many complications like this. Neuropathy, retinopathy, cardiovascular. Okay, but here there are a lot of risk factors are there. How we can identify the most influencing risk factors? So these are the 8 factors I've taken through the ranking method. How we can identify the most influencing risk factors? Okay, the first step, we classify all the risk factors into linguistic term and provide the membership function, and then we find the interrelationship between the risk factors. We frame this matrix, and then using the CFCs algorithm, transformed into the linguistic term into the fuzzy number, and then we CFCs method, we obtain the single valued. This is nothing but the distant matrix. This is our decision matrix. We take some different input and we passed into these, and we obtain the output. And the output is framed in this kind of matrix. Okay, this is the matrix, scenario matrix, and this scenario matrix is normalized. Okay, and then each risk factors are assigned the weight. If you sum it up, you'll get 1. Okay, and then using the TOPSIS algorithm, finding the positive ideal solution, negative ideal solution, and then the closeness coefficient we have determined, through which we can take a decision. So R6, R5, and R7 has got the highest ranking. The first 3 can be taken. So here, what is it? The blindness, obesity, physical activity are the most influencing risk factors of type 2 diabetes. Okay, this is the chance of developing type 2 diabetes depending on the combination of risk factors such as genetic and lifestyle. Okay, even though the risk factors related to genes such as family history and ethnicity cannot be changed, the factors related to lifestyle such as physical activity and obesity can be changed. Therefore, we can reduce the chance of affecting type 2 diabetes if we are adopting into the healthier lifestyle. So with that, let me give what are the areas that you can do research. The fuzzy optimization, fuzzy clustering is there, fuzzy implication, artificial neural network, and then applications of fuzzy logic in computer networking, data mining, knowledge management, and decision analysis. So there are so many decision-making models are there. You can explore on it, and then whatever the entropy and arithmetic operation, fuzzy number that you have introduced newly, that can be brought into the existing techniques, and you can show how far your technique better than the existing one. Okay, so with that, let me stop presenting. If you have any, these are the references that I've taken for my talk. So thank you. If you have any question, you can ask me. I'm really sorry for the inconvenience caused. those such situation occurred, some of you are there, and thank you so much for your wonderful patient listening.